All right, let's dive right into a cosmic detective story. This is a journey that starts with a simple light from a star and ends up answering one of the biggest questions about life itself. Why does it seem to prefer one direction over another? Let's get into it. So here's the central mystery we're tackling. The basic building blocks of life, things like amino acids, they can come in two different forms that are perfect mirror images of each other. But for some reason, life here on Earth went almost exclusively with the left-handed version. The big question is, why?
To get a feel for this, just look at your own hands. They're mirror images, right? But you can't lay one perfectly on top of the other. A left glove just doesn't fit a right hand. Well, it's the exact same deal for life's most important molecules. Amino acids have a left-handed L form and a right-handed D form. And for reasons we're about to uncover, biology went all in on the L form.
Now there's a sciencey word for this handedness. It's called chirality. And this property is absolutely central to our investigation. Because if life is chiral, if it has this handedness, then something out there in the cosmos must have given it a little nudge in one direction over the other.
So how in the world do you get from a giant blazing star to a specific shape for a tiny, tiny molecule? Well, we're going to follow the breadcrumbs. We're going to trace an unbroken chain of cause and effect, step by step, with no magic or leaps of faith. The journey starts with ordinary starlight and ends with the very molecules that seeded life.
Our story kicks off with the most basic thing out there, starlight. A star blasts out all kinds of light, including powerful UV rays. But here's the key. This light is totally unpolarized. That just means it's vibrating in all directions, completely randomly. It has no preference, no handedness at all. So right off the bat, we know the star itself can't be the answer. Something has to happen to that light.
And that something that happens involves interstellar dust. We're talking about these gigantic clouds of teeny tiny particles, bits of carbon and silicates all coated in ice, just floating in the dark between stars. They are the first crucial link in our chain, and it all comes down to their shape.
You see, these little dust grains aren't perfect spheres. Not at all. They're lumpy, kind of oblong. You get the picture. This makes them anisotropic. Yeah, it's a mouthful, but all it means is that they're asymmetrical. And that one simple fact is the key that unlocks this entire process.
So because these grains are lumpy, when starlight hits them, it doesn't push on them evenly. It gives them a little twist, a torque. This gets the grain spinning like crazy, and I mean millions of rotations per second. And as it spins, something amazing happens. Its spin axis lines up perfectly with the magnetic field in that region of space. It's like a zillion tiny compass needles, all pointing the same way.
Okay, now picture it. Trillions and trillions of these tiny, spinning, perfectly aligned dust grains all hanging out together in a massive cloud. What you've just created is, essentially, a single enormous cosmic filter for any starlight that tries to pass through it.
And here's how that filter works. Since all the oblong grains are pointing the same way, any light that's vibrating parallel to them gets blocked. It gets absorbed. But light that's vibrating perpendicular to them, it slips right on through. The cloud basically acts like a bouncer, letting one direction of light pass while blocking the other.
So the light that makes it out the other side of this dust cloud is fundamentally different. It's not random anymore. It's all vibrating neatly in a single plane. We call this linearly polarized light. We're getting closer, but we're not quite there yet. This light still doesn't have a left or a right hand.
Okay, we've now arrived at the most critical step of this entire journey. The source material itself calls this the crucial and least understood part. So how do you take light that's just moving in a flat plane and make it start to spin?
Well, the answer lies in what happens next. As this new organized light continues its journey, it can run into another dust cloud. But in this cloud, the magnetic field is pointing in a different direction. This change in orientation acts like a special kind of prism. It actually splits the light into two parts and slows one of them down just a tiny, tiny bit, knocking them out of sync. This creates what's called a 90-degree phase shift.
And that 90-degree phase shift, that's the whole magic trick. It transforms light from vibrating in a line to spinning in a circle. And boom! For the very first time in our story, the light itself has a handedness. It's either spinning to the left or spinning to the right. We finally have chiral light.
So, now we have our special spinning light. What's it good for? This is where the physics of stars finally meets the chemistry of life. There's a principle called circular dichroism, which just means that chiral molecules, our handed amino acids, actually react differently depending on which way the light is spinning.
Let's put all the pieces together out in space. Remember those icy dust grains?
Well, trapped in that ice is a totally random 50-50 mix of left and right-handed amino acids. When our new circularly polarized light hits that ice, it starts destroying those molecules. But, and this is the kicker, it doesn't destroy them equally. Left-spinning light is just a tiny bit better at zapping the right-handed molecules, and right-spinning light is a bit better at zapping the left-handed ones.
Now, this is a very slight preference, but over millions of years in the deep freeze of space, it adds up. It doesn't wipe one form out completely. Instead, it creates a small but persistent surplus of the other kind. We're talking about an excess of just 1 to 5%.
You might be thinking, just 1 to 5%, is that really enough to build an entire biosphere on? And the answer is absolutely. In chemistry and biology, a tiny head start is all you need. Once you have even a slight preference, other chemical processes can grab onto that and amplify it, snowballing it into the nearly 100% dominance we see in life today.
And this brings us to the final amazing piece of the puzzle. So why left-handed? Was it always meant to be this way? The answer is no. There's no deep law of physics that says left is better than right. The reason life on Earth is left-handed, well, it comes down to a cosmic coin toss.
It was pure dumb luck. The cloud of gas and dust that our sun and planets were born from just happened to be in a part of space where the light that got through was mostly left spinning. That's it. Somewhere else in the galaxy, another solar system could be forming right now under a shower of right-spinning light, setting the stage for entirely right-handed life.
So there it is, the whole incredible story from start to finish. A clear, unbroken chain of events. You start with random light from a star. It gets filtered by spinning dust, then twisted by magnetic fields in another cloud. That special, twisted light then selectively sculpts the raw materials of life, creating a tiny preference billions of years before Earth even existed. Which leaves us with one last fascinating thought to chew on. This whole process isn't unique to us. It's happening all across the cosmos. So if we ever do find life on another world, will its biology be a familiar reflection of ours, or will it be a perfect mirror image? It's a 50-50 cosmic bet and a powerful reminder that one of the deepest truths of our existence was written in the stars, all by pure chance.